Hi everyone, in this video we are going to talk about generics. So generics is basically gives us a tool so that instead of many different functions for different types, we can create just one function that works with any type, and that's called generics. So imagine that you have an application and you want to log the events. For those, what you need is you need to simply get the event and you want to convert it to a string and then record it or store it. But since we need to define different parameters in the function, we need to use many different functions to have this functionality. But instead, if we say we are going to use generics, which means that we will accept any type, but we don't know yet which type we are getting. But then we can convert this type using toString, and then we can store that string. Some types doesn't convert to a string, but like in most cases, that will be enough. So instead of having separate and repetitive functions and code, you can have just one code that works with multiple situations. Alright, so that's the quick summary of the generics, and then we are going to use them much more, and even though we used them before, especially in traits, we are going to learn how we can utilize it and how we can use this in many situations. We also saw trait objects, which does a similar job, but as we talked on that lesson 2, trait objects, they do this during the runtime, but with the generics, we have the ability to do this in the compile time. And don't worry, we are going to talk about the performance and other aspects of generics too. So let's start with defining generics. Now let's create a function. I'm going to call my function swap, and I'm going to define the generics here. So by saying t, we are actually saying this is just a placeholder, and here we are going to have any type, so that every place that we see t, we are going to use the type that we provide this function. But for this swap to work, the types that we are going to use need to have the copy trait, so we should be able to copy them. So I'm going to say copy here. So by saying this, I'm actually saying I'm going to use any type that has copy trait. So in other situations, if you don't have this specific need, you can just say t here. And then as the parameters, first I'm going to have x, and for the x we are going to say it will be a mutable reference of this t, and y is the same. It's going to be a mutable reference to t. And inside the function, I'm going to define a temp, and this temp will have the value of x. If you remember, with this asterisk, we are dereferencing it. We have the mutable reference to this type t, which is this x here, and by dereferencing, I'm getting the value out of the reference. With this ampersand here, we are getting the reference from the value. With this asterisk, we are getting the value from the reference. It's the other way of doing this. And then I'm going to say x is equal to y. By saying this, I'm actually saying the value of x, because of this asterisk, and this was the reference, is equal to the value of y, and we dereference y2 using this asterisk. So through this reference, we got the actual value. So we said value of x is equal to value of y, and the value of y is now equal to the value of x, which is stored in the temp here. So if we didn't store this in the temp here, we couldn't say the value of y is equal to the value of x, because the value of x is already the value of y. So we would lose the value of x in this line if we didn't store in a place. That's why we have this temporary variable here. So as you can see, this way we can use this for many different types that implements this copy trait. So by doing this, we are just having less work and passing much work to Rust. Now I'm going to define a trait called summary here. And inside this trait, we are going to have a function called summarize. And this function will take self. And then at the end, we are going to return a string. Now we have our trait. Let's define a function. We are going to say print summary here, and this will have the type t, but it should implement the summary trait. As the parameters, we have an item which is t. Here we said that we are going to create a function called print summary, and this works with any type that implements the summary trait here. If you remember, we said it needs to implement copy trait here, but for that it needs to implement the summary traits, because what we are going to do is we are going to use the summarize function So the type that we are getting here, if the type doesn't implement the summary trait, then we cannot use this function. That's why we have this bound, we have this restriction here. We are basically saying, yeah, we can work with any type as long as they include this summary trait, because I'm going to use a function from that trait. So if it's not that type, sorry bro, it ain't gonna happen. So here I'm going to say println, and inside this we will basically say item dot summarize. Now this function is going to work with any type that implements the summary trait, and inside this summary trait we have the summarize here so that we can use this item dot summarize. Now let's create another function to understand the bounds of this generics more. For that I'm going to say print double summary here, and now instead of one generic I have two generics, T and U. And here I'm going to have item 1, which is of type T, and then I'm going to have item 2, which is type U. Now here, before moving forward, I'm going to say where T implements the summary trait, and also U implements the summary trait and also the clone trait. And then let's start our function. So what's different here? Here we said T needs to have the copy trait implemented, and here we said this summary trait implemented. And here we are saying we got T and U, we are not saying anything about them, and before the function body we are saying where T needs to implement summary trait and U needs to implement summary trait and clone trait at the same time. We are saying this in the beginning of the function because we are going to work with the functions from this summary and clone. So any type that we are using here as T and U needs to implement this trait so we can work with them in our function without any problem. So here we are going to say println, and we can say item1 dot summarize. We are going to say the same thing here, but instead of item 1, now we got item 2. We can use this function because we know that they both implement the summary trait and the summarize is inside the summary trait, so we should be able to use them. But now I also got something else. I'm going to say clone to item, and this will be item2.clone. How I know I will be able to use this function with this item? I know this because we said in the beginning this U needs to implement both summary and clone. Let's print this out too. And here I'm going to say cloned item dot summarize. As you can see, we use many different functions like the summarize and also clone with different types. We don't know which types, but we know that they will be able to work these traits. They have these functions, so it's safe to implement it this way because we know them from here. You can see this in many Rust code. It just creates the bound for the generics that we are using. And another way of doing this is up here. And also, if you remember, we had a couple of enums that are really popular, like the option type here, which implements this sum t and also none. As you can see, we didn't have any restrictions here, we didn't have any bounds here, because we are just carrying whatever we have here in the sum. We are not using any specific functions or functionalities. Since we are not utilizing any functionalities here, we are just passing the value, and for that we set t. And also, if you remember, I'm pretty sure you do, we have a result type which has t and e. Well, it can be w too, but just write the way it is. And here we have OK, which carries this t, and we have error, which carries this e. And as you can see, we also didn't put any restrictions here, or any constraints, or any bounds, whatever you say, because we don't care literally which functionality we have with these types. We are just passing through this, And once we want to use them, we are just extracting them from these mappers that we are using with OK and error. So in these situations, we don't need any specific functionality in these types, so we are not restricting them in any way, we are just passing them. So don't think that we always need to use this generics with the restrictions and constraints or bounds, because we are not. We are just using them here like this because we need a specific functionality so that we can work with that functionality in our own functions. That's why we are putting these bounds and restrictions and everything. But the idea is just to have a generic type that can be used with any type. If we have specific functionality, then we restrict them. That's not the way to go in any situation. Now, this is the first part of the generics that we are going to talk about, and this is how we can create generics and use them with the functions that we are implementing. So it's always important to remember that there are always trade-offs with these things. As we talked before, generics happen during the compile time. Since they are happening during the compile time, they are creating the code in the compile time. So as you can see, we have this function here, print summary function, and we have these items using them. So if we use this function in our main here, and we have different types for that and using with different types that implement this summary trait, maybe we have a couple of enums or a couple of structures that are using or implementing these traits, and we are using this function with many types like we defined here. For that, we need to have a couple of functions, and we were writing generics instead of writing a couple of functions. But in this case, since it's happening during the compile time, and Rust is the one doing this for us, we are waiting a little bit longer, but once it's compiled during the runtime, we will have all our functions. So the positive side is that we don't need to consider the performance here, since it's going to be as smooth as we are not using generics, since we are creating the functions during the compile time. But since we are doing this during the compile time, the size of the binary after we get during the compilation will be larger, and also we are going to wait a little bit long for the compile time, which is actually the opposite of what we were doing with the trait objects. With the trait objects, Rust isn't creating them during the compile time, but we are just creating a table for them so we would know how to use them during the runtime, which called vtable if you remember. So this is the other way of doing things. They are implemented in these ways so that you can utilize your need. If you need that kind of behavior, you can go with generics. If you need that kind of behavior, you can go with trait objects. So that's the introduction for the generics and the basic implementations and usage of the generics. So thank you very much for sticking with me the whole video, and I will see you on the next one.